Topics1234Enzymes. Welcome to this instructional video on metabolism and energy in biological systems. Today, we'll explore the fundamental concepts of how living organisms manage energy and the biochemical pathways that power life. Metabolism refers to all the chemical reactions occurring in an organism. These reactions are organized into metabolic pathways, which are sequences of reactions either building complex molecules or breaking them down into simpler ones. There are two key types of metabolic pathways. Catabolic pathways break down complex molecules to release energy, while anabolic consumes energy to build complicated molecules from simpler ones. Energy, the ability to do work, is essential for organisms to survive and function. Energy exists in many different forms. Kinetic energy, energy associated with motion. Thermal energy, energy associated with the movement of atoms or molecules. Potential energy, stored energy. Chemical energy, a type of potential energy available for release during chemical reactions. Now, let's discuss the laws of thermodynamics, which govern energy transformations. The first law states that energy cannot be created or destroyed, only transferred or transformed. For example, a squirrel transforms the chemical energy from a nut into kinetic energy when running down a tree. The second law tells us that energy transformations increase the entropy, or disorder, of the universe. During these transformations, some energy becomes unusable, often lost as heat. As the squirrel climbs the tree, some of the energy is released as heat. Scientists use the concept of free energy to predict whether a reaction is likely to occur. The free energy change, delta G, determines whether a reaction will happen spontaneously without outside energy. Exergonic reactions release energy and are spontaneous, such as cellular respiration. Endergonic reactions absorb energy and are non-spontaneous, like photosynthesis. Adenosine triphosphate, ATP, is the molecule that cells use to store and transfer energy. Cells harness energy by breaking the bond between ATP's second and third phosphate groups in the process called hydrolysis. This energy is then used to power cellular processes, such as movement, transport, and chemical synthesis. Reactions in cells happen quickly thanks to enzymes, which are proteins that lower the activation energy required for reactions. Enzymes have a specific site called the active site, where substrates bind. They can either break down molecules, catabolism, or build them up, anabolism. Enzymes function optimally at specific temperatures and pH levels. If the temperature is too high or the pH is outside the normal range, the enzyme may lose its shape, a process called denaturation, which affects its ability to function. Inhibitors are molecules that reduce the activity of enzymes. Competitive inhibitors block the active site, preventing substrates from binding. Non-competitive inhibitors bind elsewhere on the enzyme, altering its shape and making it less effective. Allosteric regulation and feedback inhibition. Finally, cells regulate their enzymes through allosteric regulation. Molecules bind to allosteric sites, which are different from the active site, to either inhibit or activate the enzyme. Additionally, in feedback inhibition, the end product of a metabolic pathway can act as an inhibitor to an enzyme earlier in the pathway, helping the cell maintain balance. Understanding how cells manage energy and control metabolic pathways is crucial to grasping the complexity of life. This interplay of energy, enzymes, and regulation allows organisms to thrive in diverse environments. Thank you for joining me in exploring these key concepts. I hope this video helped clarify how life is powered by intricate biochemical processes.